Dakota. We got three presenters today that are going to present on three different topics from around North Dakota this last year. One is a stone matrix project on I-94 or on I-29 north of Hankinson, which includes a high durability surface course of minimal rutting. The second is a high reclaim asphalt pavement project near Valley City, which was a test project to utilize higher percentage of recycled material into hot mix asphalt. And then third is going to be the North Dakota 1804 project southeast of Bismarck, which included several test sections utilizing smaller nominal maximum size aggregates for thinner overlays. First up is going to be Mark Riley, our highway maintenance coordinator in the Fargo district. Mark's role at the NDDOT Fargo district includes overseeing the district's and projects field lab, running the Fargo district's independence assurance testing program, and assisting the NDDOT technical certification program. He earned his associate's degree in civil engineering and surveying technology from the North Dakota College of Science. Next up will be Danny Schmidt, quality control manager, Knife River Materials. He specializes in asphalt mix designs. Danny works closely with the aggregate production to ensure the seamless transition to asphalt production on Knife River's paving projects. In 2009, he started working in the quality control lab at Knife River as a field supervisor. Today, he is still in the lab and serves as the quality control manager. He earned his BS from Bemidji State University in industrial technology with an emphasis in construction management. And last will be Aaron Perez, our pavement section's team lead, Materials and Research Division. Aaron joined the DOT in Bismarck District Materials and Research Division back in 2018. Aaron's current role as Materials and Research includes leading the pavement design team, overseeing the falling weight deflectometer and pavement smoothness activities, and the evaluation of material related testing and specifications. He earned his BS degree in civil engineering from NDSU. So please welcome Mark Riley.
Okay, I'm going to talk about the stone matrix projects on I-29 from Wahpeton to just north of Galchute is where it took place. It consisted of some super elevation corrections, approach panel structure, the structural approach panel replacements, approximately 370-foot long piece of PCC pavement reconstruct under annual separation, and then cracking and seeding the existing concrete to the point where it had no load transfer, so the SMA and the FA 45 that went on top remained as a flexible pavement. So we put about 1.5 inches to 2.5 inches, depending on where we were at, of the FA 45 as a base course, and then a 2-inch SMA overlay over the top with some CPRs and mill and overlay work on the ramps and crossroads. So the stone matrix asphalt was developed in Germany in the 1960s to help resist deterioration from snow tires on their studded snow tires on their high volume roads. And they first used it in 1968 near Kiel. And the SMA technology was brought to the United States in the 80s, where it didn't get used until in 1991 when Wisconsin, Michigan, Georgia, and Missouri all used an SMA project that first year. And the DOT, our first project was 2016. We did one on I-29 from the South Dakota border up to mile point 11, and then 17 was the second one, and it was either 18 or 19. Valley City did the third project, and so this was the fourth, and next year we'll have the fifth project in the Fargo district. It's currently used all over Europe, Australia, Canada, and the US, so the North Dakota DOT is using the SMAs because of its resistance to rutting and load carrying capabilities on our high volume roads like the interstates. So what is an SMA? It's a highly fractured coarse aggregate gap graded asphalt mix. It's typically 70 to 80% coarse aggregate, 8 to 12% of a mineral filler, which is typically either a Portland cement or a fly ash. The 6 to 7% AC binder, and then a 0.3% of a stabilizer or fiber or a strand. And then what's typical or unique about the SMAs is it develops a stone-on-stone skeleton in the mix that helps it carry the loads. So, and typically the HMA's projects require a chip seal every 3 to 5 years. The North Dakota DOT currently on the existing SMAs in the Fargo district has only done some crack sealing. And future is to look at possibly a fog seal of the entire coat sometime in the future, but when we looked at them last summer, there was no need to do anything yet. Long-term preventative maintenance or rehab would be to do a micro mill with an ultra thin bonded wear course possibly, or even a reconstruct mill and SMA overlay for that. When it comes roughly 20 to 25 years old is what we're hoping for. So this slide here is the states that are routinely using the SMAs, and then the ones that we're using a little bit, like North Dakota, and there are some that have no response, but states that are routinely using it have a quarry system in place where the hard rock is being quarried and crushed quite frequently for those projects. The ones that, like North Dakota, we don't have a quarry system for our rock. We have all gravel deposits from the glacial till. So I just thought that was an interesting slide to give you a heads up of who was using it, who wasn't. And so the SMA specification or SP is you can see the gradation up there. So typically on the SMA, your number 4 is a 24 to 34% passing, where on your dense graded asphalts it's about 70% passing the number 4, which, and then you see your 200 is 6 to 10%, and on a dense graded is 2 to 7. And then, and then it's your dense graded is only 1 fractured face requirement. The SMA has 2 for your mix, so it's 90% 2 face, or 95% 1 face of fractured faces. And then your flat and elongated, there's 2 specs there, a 3 to 1 and a 5 to 1, versus the dense graded is just a 5 to 1 at 10% max. This is just some more of the requirements off of the SP. About the only thing you see difference there is the drain down test is added to the SMA SP. And that's why your fibers are added into the mix, is to hold the oil in for your long-term transportation or holding of the asphalt so the oil doesn't leach out. And so the drain down test, you put a gyratory plug on a oven safe plate, and you get your tare weight. Then you would fill a basket full of your stone matrix and you stick it in the oven for an hour. Then after the hour you weigh the amount of oil that was left on that paper. This year in the SP, the VCA was not part of our SP, the voids and coarse aggregate, that has been put back in. And that's just to the, okay, let's see, VCA is the dry coarse, rotted coarse aggregate, which is, you need the specific gravity of the combined coarse aggregate. And then it's, your VCA numbers should be greater than 1% over the VCA of your mix. So this is the project mix design. You can see that we used a 58H minus 34 oil. And all the aggregates come from LG Everest granite out of Ortonville, Minnesota. And then we did use the Cold Creek fly ash, which is readily available. So this is an aerial picture of the SMA plant, which is similar to your normal plants with the exception of you've got the line silo for dumping the fly ash into the aggregate production, and then the powder pig that's sitting there that you would normally only see on a concrete plant. And then you got that blue box right in the middle about where the wrap collar is. That's where the fibers are shredded. The bales of fibers come in a bag about the size of blown insulation or compost if you buy garden compost, and then they run through the little mill there. I got another picture here of that mill. So that's the fiber mill, and then that hose right there runs off to the backside and then is injected into the wrap collar. And this is just the picture of the asphalt laid down. They goes down similar to your normal mixes with the exception of this is very temperature variable. A windy day will suck the heat out, and it's hard to get compaction on an SMA mix if you lose your heat. So good windy day, even if it's 90 degrees out, the rollers are going to be almost on top of the paver, which is different to see, but if they're not up there, they won't get density. And this is a cross-sectional cut of gyratory plug. Of the one on the left is the SMA, where you can see the stone-on-stone skeleton of the mix. And the one on the right is a cross-sectional plug of an FA43 from last year in the Fargo district, that you can see that it's a pretty dense graded mix versus the old gap graded for the SMAs. And then some concerns, one of mine and the contractor's biggest concern was losing too much of the minus 200 into the bag house. And on this project, the contractor did contemplate injecting the fly ash into the drum to keep from losing too much, but then they chose to go back to the line silo like it's typically done in this area. And then the contractor was really worried about achieving compaction since they didn't get started until late summer, almost early fall. This is a copy of the first district. I pulled a burn off on it just to see. The day we were doing this, the contractor was trying to push the plant about 350 to 370 ton an hour. And you see our mix design was 9.8% passing the 200, and we got a 7.9 after the burn off. So assuming we were losing some of the fines that I was concerned about into the bag house, and they did have to shut down and clean out the bag house a couple of times the first day, and then periodically. And then I just noted the 3/8 and the number 4, the difference they were from the mix design, what I got for the burn off, just is a concern. I didn't know if they were segregated from when we pulled our rice and our gyratory plugs, and then I used what was left for a burn off. So just I noted it just because I wanted to see if it was consistent or what. So that's why there. And then this burn off was about a weekend, and they had slowed the plant down at this point down to about 300 ton per hour. And you can see that we got just about a 9% passing the 200 on the burn off versus the 9.8, which could have been the amount of material I went up the chimney of the burn off oven. But then notice that we had some difference from the mix design again, so just noted it to see if it was segregation on our end from when we were pulling the sample or what was going on. So that's all I had. You guys got any questions?
So we talked about the making the density more of an issue. Has there been any times when we've had
I am not aware that, I don't believe Brian's shaking his head. No, the first two in Fargo we did not. I don't see Kevin in here from Valley City. I don't know if they did in theirs or not.
I believe they use Evotherm.
You said they did use Evotherm?
just for like cold mornings or something like that? Or
I think they're doing just more workability issues in general. I think they just were struggling with that. So I don't think it was more than they said they probably would get another testing job.
It's a sticky mix, and it's not very easy to work with. So
Well, I mean, Evotherm, even a small dosage of the Evotherm will extend that out.
How does the cold feed compare to the bird?
the cold feed was pretty much right down the gradations. So, and like I said, I didn't know if it was a segregation issue because I took it off the end of the sample at the end to do the burn instead of.
I mean, it's pretty crazy that your gradation came back at the bottom. It was just the 3/8, the 4, and the
Yeah,
like
it's.
the 8, but then it came back.
But there's not much to the SMA below the. It's mostly 70% above the 4. So. All right. I guess if no more questions, I will turn it over to you up next, Danny.
Okay. Check. Got me? Okay. Mine's probably not quite as exciting as Mark's. We did high wrap. Project was on North Dakota 36. It was up by Pingree. Kevin's not in the room, is he? Nobody. Okay, so this was 28 miles, mill and overlay, 42 FAA wrap, and the requirement was 35% wrap to run in this mix. It's just another plan shot here. So from Pingree going to the west. So it took us 12 days to pave it, 56,000 tons, like I said. In the 430 description was replace the 430 and construct it using 35% wrap. Not really any other changes to it. So we got a couple plant pictures here. Our mix design, pretty standard. It's a 42 FAA. We ran 58 S34 AC on it. We didn't run any kind of modifiers. 75 gyrations. We were a 3/8 add. That was the one thing with adding 35% wrap in the mix. You're gonna have a little bit less on your add oil because you have more wrap, you have more oil in there. But 21% natural fines, 23% 5/8 rock, 21 pep dust, 35 wrap, 3/8 add. Blend adjustments, we got going right away. We were just a hair low right out of the chute, so we dropped a tenth of oil, and a couple days later, we were right at the bottom of our air voids, right around that 2 mark, and we just made a bend adjustment, dropped 2% of rock out. And density, 90% of the available out there. There was around $110,000 available on this project. So we were able to capture 90% of that on the density side. And then we did have some performance testing pulled on it. This is where I told you were going to come in, Bobby. So this was off of, so we have 3 different tests here. The first one was June 1st, second one was June 8th, and then June 15th. So 3 completely separate samples. They were IAs. Pretty common as far as our 200 was, you can see our gradation was coarser on that test number 1, whatever happened there. 43 FAA, 95% fractured faces, all of that's right there. Sand equivalency, pretty close. Air voids, 3.1, 3.8, 2.8. So all that was, everything was pretty consistent. Production Hamburg, we can see here we ran it out 20,000 passes. Pretty similar, 6.4, 6.3, 6.8. Anything to add to that, Bobby, or? Yep, so it's going to be stiffer. Yeah, so here's our ideal RT. Test 1, test 2, test 3. So 100, 102.8, 103.7. Shear strength's all about 1.5 million. Fractured energy. Now we didn't do any any performance-based testing beforehand, so I guess we didn't really have anything to compare it to other than the data that we have from the other projects. So on average, we're about, would you say this would? Yep. Okay. Okay. Sounds good. Checking comparison there. So we had our ideal CT. So there's your cracking. For whatever reason, test number 2 was lower. Yeah. Mm-hmm. Yeah. So I mean, if you were to average these out, obviously that one's a flyer, but the other 2 you'd average around a high 50 on that. So, you know, pretty good compared to what we're seeing, right? Mm-hmm. Yeah, like I said, it was a 58 S34. It wasn't an H. We didn't add Evotherm into it. It was a 58 S34 oil. So not a lot on it. We ran 35% wrap. Obviously, there's keys to having your mix work out. Very consistent. Only a couple blend changes. We didn't chase anything around. We set up. We got it done. What kind of questions does anybody have about this project? Great question. For those of you that didn't hear, Brady asked if we were anticipating any fluctuations in our wrap, and if we were anticipating that, how would we stay ahead of it? One of the things we do is we go out prior to production, take samples off the road, we do our mix design, and then it's just processing our wrap. I'd like to say we did something special, but we didn't. It was standard procedure for us. We typically will run 25, well, on the low end, 21 to 31% wrap in our plants when we're on the Minnesota side. So coming over and doing 35%, it is a step up, but our plants have ran as much as 35, 40% wrap in them before. So there wasn't really a concern on the production side with that. And then processing it, we build the piles with the drive over and have not seen issues yet. In the Grand Forks district, we're typically running 25%. We had a project on I-94 for the Valley City district after this project, and we ran 25% wrap on that. We didn't see any fluctuation there. If I remember correctly, it was 1.5 inches, and we put back 2 lifts, I thought. Yeah, I don't remember there being a lot of correction on that, but it's a great question, Ted. That was one I thought about before I walked up here, and I go, I forgot to check what the milling depth was on it. But yes. Yep. Big issue with wrap is if you can mill 1.5 inches all the way across the mat, fantastic. You're getting the same thing. What Ted's talking about is what do we do when we do these 1-inch mill to daylights? You know, and maybe you're grabbing some mix and you're getting nothing but maybe a chip seal out on this side, and then how does that pile get built? Anyone else? Yes.
So you said you normally run 25 to 30% over in Minnesota.
Yep.
So I guess I've been told by certain people that their plants can't run higher than 25%. What makes your plant different?
So plants obviously can be set up different. That'll depend on the flighting in the drum. We have one of our plants down in Iowa that works out of Nebraska, and they'll run 55% wrap. So there is some stuff technically with the plant that can make a difference. Obviously the size of the plant will have a little bit of impact on that, and then the flighting, and so not every asphalt plant is equal. Counterflow. No rejuvenator. That was not part of the project. But that's a great question. It would be something to think about in the future if we. Now this was the first high wrap SP that I'm aware of in the state of North Dakota. I was told we got another one coming up this year. Is that correct? Thank you, Aaron. Where's that one located? Fargo district. Mark's got a lot of SPs this year. It got pushed back? Okay. Was that going to be the similar spec, 35%? Okay. Has anybody else had any, I don't know who all we got in the room, any other thoughts about trying that in any other districts? Or Kurt, we can do it. It's not that much farther to go. Okay, with that, I'm going to turn it over to Aaron. Your mouse is just not resistant.
Yeah, it doesn't.
Yeah. Yeah.
Green is good. Afternoon, everyone. So I'm here to talk to you about some structure work we did on 1804 this past year, going through Bismarck and south of Bismarck. My name is Perez. I'm the pavement section team leader, work at NDDOT Materials and Research. So with these pavement preservation jobs, we had a few objectives when we started this. The first one was to evaluate constructability of different pavement preservation methods, develop specifications for these methods to be used on future projects, evaluate the performance of them as time goes on, find preservation methods that utilize RAP. That's something that, thinking about sustainability is always something that should be on our minds, and encourage districts to use these methods on future projects. So these two projects we had, as I said, they're both in Bismarck, both done by CSI or Central Specialties. So we had a north project and a south project. So the north project was 23223 PCN. That was from the expressway down to Signal Street on University Drive. That had some curb ramps, milling, HMA, and lighting. Was about 6 miles. Then the south project that butted up next to it, that was 23336. That was from Signal Street down to Hazelton Corner, and this is the one that had various surface treatment test sections, and that was for about 25 miles. So we'll start with the north project. So what made this difference is we used a 9.5 millimeter mix. So that was a Superpave FAA 45, just down to a 9.5 millimeter, using H-34 oil. Just under 19,000 ton of asphalt was used, 15% RAP. VMA minimum was at 15%, which normally we're running at 14, but because of this, we decided to kick it up one. This was a mill and fill of 1.25 inches, and the aggregates were from the Weinman Pit in Tuttle, North Dakota. So the differences between the 9.5 and our regular 430 mix. So our regular 430 mix is, we run at a nominal max aggregate size of 12.5 millimeters or a ½ inch. So this chosen was just, what we're doing is decreasing the nominal max aggregate size, which really means we have a higher fine aggregate percentage. So why did we decide to do this? A few benefits that we are hoping to see and saw right away as it was getting paved. Decreased permeability because of the increased fines. Surface appearance, that was a very tight mix. If you went out there and drove it, it looked awesome. Less susceptible to segregation because of the lack of the coarse aggregate in it. Can be placed in thinner lifts. This was in 1.25 inches, mill and fill. Another tool in the toolbox as far as something that we can use in these types of applications where we don't want to be putting too much down, especially if we don't want to widen. And right away, this thing rode awesome. 31 MRI for a 1.25 inch lift. So just a mill and fill. So going into the south project, which is where we get into our test sections here, we had 8 total test sections, 3 miles each. All of them had a ½ inch micro mill, and all the aggregates used in all these were all locally available, coming from various pits around the area. So we had a working group that met once a month for about 6 months, working on these SPs and plan notes. Also got a lot of feedback from contractors and guidance from other AASHTO guidance documents, and just talking with everyone here in this working group with M&R, construction, maintenance, planning and asset management, environmental transportation services, and then talking to contractors. And I guess this would be a good place to say too, kind of the mastermind behind this was Tyler Walmuth. He couldn't be with us today, but he was a big part of getting this kicked off. So here's what we did on this test section project. So going from south to north, we started with a double chip seal, then went into a cape seal. And for those of you who don't know what a cape seal is, it is a chip seal with a micro on top of it. Then going into a wrap cape seal, a double micro, wrap double micro, ultra thin bonded wear course, a 4.75 millimeter HMA thin lay, which is similar to the 9.5, just getting even smaller, and a 2-inch wrap FAA 43 as a control. So to go through some of the sections here, that's a little small, but a couple pictures here of each section, and kind of go through some of the costs. So like I said, each one of these was around 3 miles. So our double chip seal came in, and this is just based on this project, mind you, came in at about $194,000 dollars a mile. Section 2 came in at about $166K. The wrap Cape Seal came in just a little bit higher, which I thought was a little impressive, actually. We thought that would be a lot more expensive, so it's something to keep an eye on. Double micro surfacing came in at about $160,000. And going into the wrap double micro, about $163,000 per mile, ultra thin bonded. This one was the more expensive one, came in just over $400,000 per mile. And I guess to note too, with these ultra thin bonded and the 475 HMA thin lay, they were both done in 3/4 inch lifts, one lift at a 3/4 inch. And then our last section was our traditional overlay, that came in just under $400,000 per mile. So on this test section project, CSI was the prime contractor. They paved the 2-inch FAA 43 overlay. Then Aztec Industries was a sub, did the thin lay, the ultra thin bonded, and then all seals and surfacings. And one thing from this picture too, this was the first time that I'd ever seen a spray paver and a shuttle buggy used. Something you don't see very often, but it was pretty cool to see. Let's see if this works if I press play. Here's a couple of videos of the spray paver that was used. Yeah, it does work. So this is on the outside, looking in. That's hit in the middle of the driving lane. And then another back on the outside. So the spray paver was part of the SPs for both the thin lay and the ultra thin bonded wear course. They used a CRS2P oil. And I guess the nice thing about this, after being on projects in the past, using a spray paver, there was no wheel tracking for any of the dump trucks. You weren't stepping on tack if you were a ticket taker. I mean, no one was stepping on tack, so it was all there, just coming really clean. So I think that led to a really good bond with these preservation methods. So these were done in this type order of operations. They started with the 2-inch FAA 43 overlay, went to the 4.75 millimeter, then the ultra thin bonded, all virgin chip seals, came back and did all the virgin micro seals, which that would include the Cape seals then, and then ended with the wrap seals. And here's a picture of the separator separating all the wrap chips there. So as I said, wrap was done last, and there was a reason for that. Breaking down these chips did take time and wasn't super fun. That was something that we had dealt with on a previous wrap chip seal job that we had done. Whenever the wrap pieces were put into the crusher, they would gum up the screens. So it did take a little bit longer than anticipated to get it done, but I can tell from the center picture that's them trying to get all that gummed up wrap off the screens. But it was still faster than the last one we did, that's what I was told, so that's good. Oh, and I went too far back. Here's an up-close picture of what was paved, starting with the 2-inch FAA 43 on the left, moving to the 475 thin lay in the middle, and the ultra thin bonded on the right. I think this is a good representation of seeing, on our traditional FAA 43, seeing the coarse aggregate visually at the top, getting into the thin lay and seeing that it's definitely not as coarse. Getting the ultra thin bonded, which is the complete opposite animal. That thing looks like a mini SMA. So it's very interesting to see, and that ultra thin bonded definitely broke some records as far as performance testing goes, especially compared to our regular mixes. So it was pretty cool to see. So what are we doing with this going forward? Starting with visual observations, some of these are going to take time to see how they last. Condition data collected with our NDDOT pathways van. After evaluations, finding more tools in the toolbox to be used for pavement preservation practices. So that's all I got. I'll take some questions, and I would encourage anyone, maybe not today with the snow coming down, but if you're ever in the area and want to drive this and check it out, I would encourage it. Any questions?
So Aaron, on the university job, I remember, was that the one when bidding? I don't think it was something major like the 9.5 millimeter aggregate, but wasn't there some kind of specialty aggregate product that was going to have to be brought in from a quarry far away on that job?
Defer to district staff in here.
Maybe it's a different project.
It might have been a different project. Where's Dan at?
Was there a specialty aggregate product on a local Bismarck job, central specialty kit within the last year or two that I thought had to be brought in from the
I didn't,
Minnesota? Okay.
thanks, Dan. Best project engineer.
Found the local,
Yeah. Per mile. Mhm. Yeah, it was more expensive than our control.
Looking at the project as a whole, the existing conditions, weather, construction techniques, and all those factors, you think each treatment is in a position to succeed? Is there any, do you have to caveat any of the results with, well, this one didn't do well, but we think that might be because of this?
It might be too early in the game, I would say. I think during construction, everything went as planned. I guess we're really hoping that there's a place to use some of these treatments sooner than later. So we're really hoping to see them hold tight through this winter and hopefully the next few winters and see, because if we can start putting out some thinner pavement preservation type methods out there, I think that'd be a really great use to the state.
And it's obviously not, complete year yet, but
Right.
driving, any initial takeaways on this?
I've driven it once. Reflective cracking is still a thing. So I think that's always going to be there, but as of right now, I haven't seen anything that's leading me to think that this is going in the wrong direction yet. And I drove it last week. So.
But now they're, that's a lot better than before.
Yeah, no, I would agree. It was pretty.
Having like the plow drivers or anything, I mean, it's been a mild winter, but having the plow drivers that go in and do some different inspections on, things with more swiftness on certain ones and others, or?
I don't know the answer to that question. I haven't talked to any maintenance staff on that. I guess Bismarck District, have you guys heard anything from anyone? I'm assuming not. Okay, well, thanks everyone.